All right, continuing on to our 1.6, starting with question 10. My apologies for the delay, but when I was solving this, I was getting very odd number, like fraction of a fraction of a fraction. So I thought I was doing something wrong, but after consulting with Carlos, he happens to be one of the prof. Seems like I'm on the right track, and I made sure I check all the numbers with him. So this should be a perfect solution. But if you see anything weird, let me know. But I'm pretty confident about this. So again, nothing too different from question 9. It just looks complicated because you have a bigger matrix and more, So, but it's the same idea. So I'm not going to go through these necessarily because I've already actually wrote down what I actually did, right? So you guys should be able to just see it and it's like, oh, well, okay, I'm on the right track. Or wait, why did it wrote this way? Maybe I screwed up somewhere, right? So that's what's going to happen, right? As you probably noticed, starting here, right? So from 29 to, negative 29 to negative 29 over 2, that fraction is going to snowball into something really ugly later on, right? But, rest assured, that doesn't mean you're doing it wrong, okay? It just happens to be a very ugly algebraic outcome. But nonetheless, math is pretty straightforward. So feel free to follow through this. And one thing that I didn't have a space to write, but hopefully you guys will just understand, is that once we put it into identity matrix, yeah, you guys can say identity matrix. Yeah, you can say, yeah. Once you make it into identity matrix, you're going to have these values, right? So these 3 values are now your x values, right? So this is 3 by 3, right? So this is x1, x2, x3, right? So that first one, negative 18 is going to be x1, negative 1 will be x2, and negative 14 will be x3 for the first 3 possible, possible constant outcomes. So when x1 equals negative 18, and x2 equals negative 1, and x3 equals negative 14, you're going to have b1 of 0, b2 of 1, and b3 of 0. And you can always plug it in to check, but I'd rather not do it here. Space is as precious as it is, but it will come out that way, right? So next one's going to be, unfortunately, not very pretty, but 25 times 13 plus 2, all that add to 25 times 9 divided by 2. Maybe if I do this, it will look a little better. Right? So that whole thing, whatever it may be, hopefully comes out to a nice number. I sort of doubt it, but nonetheless, that is going to be your x1 value, right? And negative 25 over 2 will be the x2. This will be x3. So if you plug these into x1, x2, and x3 into this original matrix, it will give you the b1, b2, b3, which is a different scenario, right? Negative 3, 4, and negative 5. It will be different because we're punching in different x1, 2, 3 values, right? So depending on if you choose this one, you're going to get this outcome. If you're going to choose this one, you're going to get this outcome. That's all there is, right? So on your answer, even though I didn't write it, mention something like that, right? And then you should be all set. So say something like how when x, maybe I should, okay, I wrote it out here, so you guys, I should be able to erase it. So what I'm going to do is I'm just going to erase that. If you need to go through, just go back to the earlier video and then just freeze the screen so that you can check yourself. But nonetheless, so if I have this, it's going to be like, let's see, what could it be? So x, which happens to be, you don't have to write this, right? But that's essentially the same thing as this, right? So this will be negative 18, negative 1, and negative 14 for b1 equals to 0, b2 equals to 1, b3 equals to 0. So, it doesn't have to be exactly this. I think the solution manual possibly gives you a different format. I haven't had a chance to look at. Okay, so yeah, so they don't do this, but they basically, for system 1, that's what they call it, right? So, yeah, so remember this B1, B2, 3, rather than just going like this, they just say this is going to be system 1, right? So for system 1, x is going to be negative 18, x2 will be negative 1, x3 will be negative 14, right? So honestly, either way works because, they're really saying the same thing, right? Just, different format. But so I wouldn't really worry too much about it. But, just be very clear about what you want to say, right? As long as your answer format is clear as to what, the x1 and 2, 3 mean in relative to the B1, 2, 3, I think you're good, right? So write something like this, right? And this, by the way, this is not this is not the final answer, right? This is only explains one system, system 1. You want to write like something similar like this for system 2 as well. And depending on how many systems you have, you may have to write 3 sets of solutions for system 1, 2, 3 respectively, as we will be doing in other questions, right? But nonetheless, that's what you're expected, right? So that's 10. This is 11. So looks a lot simpler, simply because the matrix dimension is only 2 by 2. But nonetheless, same idea, right? So I made the first matrix into the identity matrix. I've shown the steps too, so you can follow through. Or if you have a solution manual, check that as well. Which is actually, speaking of which, yeah, if you have my videos, then technically you wouldn't need to buy a solution manual. Food for thought. Yeah, but then solution manuals come with the textbook, so. Okay, well, we'll see how that goes. But nonetheless, yeah. So this is how I solve them. Nothing too difficult, right? Just flip that and then, yeah. So there's not much more to say, right? So here this is a little annoying, right? So for example, I don't know, you could say system 1, whereas B1, B2, B3 equals to, what was it? 0, 1, right? Oh, no. There's no B1, B2, B3 for this one. Because there's B1, B2, right? So you're going to put B1, B2 equals to 0 and 1. For that, x has to be negative 15, or x1, and x2 will be 4 over 15. That's system 1. How many systems are there? 1, 2, 3, 4. So you're going to write this thing for system 2, system 3, system 4. It's a little tedious, but because it says all in here, but I would write it down, considering how it went for quiz 1, about how little details can really mess up your grades. Just play this, right? And if you run out of time because you're stuck in other questions or whatever, maybe just finish this, because that way at least most of your answers are out there, and finish the other questions, and hopefully by the time when you have time, go back and simply copy paste, right? Actually, that might be a bad advice because you rather get yeah, I suppose you want to get as many questions perfectly right as possible in some situations, right? Like if you half-ass for 4 questions and get half-ass grades, that may not be as good as getting 2 perfect answers. And well, I don't want to dwell in this scenario because you should be getting all of them right, or pretty much close to being right, right? Anyways, so that's that. And I'm gonna go into the next one. 12. Yeah. Okay. So again, similar idea. It just looks a little bit more complicated because now you have 3 by 3, and then you have 3 systems. But again, it's the same idea. If you think about it, this is almost like doing inverse question, right? In terms of dimensions. But nonetheless, same idea, right? So you have this time, fortunately, we have really nice numbers, but same idea, right? So it's gonna be when you write the solutions, it's gonna be like, let's say, I don't know, system 1. And this time we have 3 B's, right? So B1, B2, B3 equals to 1, 0, negative 1. Then x1 is going to be negative 18. x2 is going you guys can say. x2 will equal to negative 9. And, whoa, what's wrong with the pen? No, it's just me. x3 equals to 2, right? Okay, maybe write a little better than this, but you get the idea, right? So system 1, system 2, system 3. Do the same thing with respective numbers, and then you should be good to go. Yeah, so that was unusually fast. Maybe I should be doing this way from now on. But nonetheless, yeah, so that's 12. We will get to 18. So this is question 18, A and B, that we're going to discuss. Maria has gone over this with the class, but I was one of the unfortunate who couldn't quite keep up. Like I understood sort of where she was going, but didn't have a complete understanding as to how the question works. So hopefully this helps. But if you're smart enough to follow through her material, then kudos to you, and feel free to just skip this video and go to the next one, 1.8. But nonetheless, I'm almost certain this will be on quiz 2, midterm as well. I mean, because of the nature of the question. So, maybe go through with me. It might save you some time during the test. Anywho, so we are given with matrix A. We're given with X vector matrix, right? Every time there's a line there, that means vector. It means it has some kind of a direction, right? Which actually gets important because when the question asks, prove that AX vector equals to X vector is the same thing as A minus identity matrix. That whole expression times X vector gives you 0 vector. Now, one of the things that I was stuck with is, what's the 0 vector? Like 0, 0, isn't it? Just because vector means with direction, right? So it may be 0. You guys can see here. So if it's just 0, then 0 is 0, right? But if it's 0 vector, right? Yes, it's still 0. But let's say depending on what the vector is, let's just say it had three x's, right? x1, x2, x3, right? You will say this. And this is different from this. And magnitude-wise, they're the same. You're right, but not necessarily if it has a direction. It has 0, 0, 0. So when would it make a difference? Let's say when you are subtracting them, for example, right? You won't be able to do a minus 0, right? Because it's got to be 3 by 3 minus 3 by 3. As an example, right? So anyways, that's a little trivia thing. Right now, not too important, but it may become important later on. So try to appreciate this little technicality. They may snowball into something more important later on. But nonetheless, so this is what I did. Okay, so I have to prove that this equals to this. So how would I go about doing this? Okay, so what I first did, like any other algebraic questions, I just substituted all the variables with the actual inputs that we have. So A we already know is matrix, so I just subbed it in. X we already know, x1, 2, and 3, so I subbed it in, and I did the same thing over here as well. So that's all good, right? So what I'm trying to do is, well, I can subtract this. I can subtract the x vector here, and as long as I do the same on this side, right? So I'm going to subtract by like that and like that. And I know it looks very algebraic, but according to the linear rules that we learned from linear matrix, linear algebra, or matrix rules, we talked about those, right? This is, as Maria would say, legal. We can perform this because it's by the same dimension, right? So I'm actually going to do that right now. So I just put it in this way, just so that people are more clear on what I'm doing, right? Ax vector minus x vector equals 0, and then just sub them together again. So a and times x vector minus this vector equals to 0 vector, right? Now, one thing you notice is I can factor out the x vector, right? So if I do that, I'm going to get this. So I'm going to x1, 2, 3. Or you can factor out the other side, up to you. It doesn't really matter, but I did it in front because of the space. But then, so you have a minus. Now, this is the thing, right? So if you factor out x vector, and then, because it's here, right? So this times whatever will have to give me x, y, 2, and 3, right? Vector, right? If this and this is identical, the only possibility of this, where if you times this by this gives you that, has to be identity matrix, or 1, right? But we can't use 1, right? For the similar reason we talked about, right? It's got to have direction. So 1 with direction is the identity matrix. So that's why I plugged in identity matrix here. 1, 0, 0, 0, 1, 0, 0, 0, 1. Pretty clear, right? Simple factoring, right? So after that, all I did was, hey, wait a minute. So let's just plug back the variables back. So that's going to be x vector equals a minus I equals 2. Yeah. See, I'm still making this mistake. 0 vector. So that's the same thing as, because remember, our dimensions are the same. So we can switch the order, right? So it's going to be a minus I times that. It gives me that. Okay. Now, does that look like this? It totally does. So we proved it. Now here's the thing though. When we say proof, we have to be able to go both ways, right? So yeah, okay. I guess this technically would be enough, but Carlos and Maria too, I think they say we need to approach from left hand side and right hand side, so both ways. But technically, if you argue, we went this way, so if you do exact reverse, we'll get to the same place. So hence, we don't need to do the other way because it's just reverse process, right? But nonetheless, I did it anyway. So maybe we could ask our profs as to is this sufficient or do you want both, right? So because ultimately, they're the ones who grade them, right? So ask your professors to make sure what works for them. But nonetheless, let's assume the worst case scenario, and we have to do both left side and right side, right? So if that's the case, then a minus I, the whole expression times x vector equals to 0 vector. Okay, so again, I just sub it back in, right? So it's going to be this, and identity matrix, that, right? So I'm just going to times those two together, right? So it's going to be a and x, a vector, and it's going to be identity times vector, right? And that gives me 0 vector, right? So what I did here was, so if you did that, and then you just convert it back to the variable, right? Ax vector equals to identity matrix times vector. Identity timesing any matrix by identity is like timesing by 1, right? It's going to be the same thing, right? So that just means a vector x equals to x vector. And this happens to look exactly the same as this. Therefore, we prove that they are identical, right? I do realize that maybe we don't have to sub in a matrix. Now that I think about it, I just did it this way because yeah, okay. You know what? Maybe I went overboard. Technically, I think you could have just done this. But she didn't do it this way. Oh, no, she sort of did using this way. Yeah, so you could have just done this, right? And then you could have said, this one you could have just done holy crap. I think you could have done this way. It would have been so much easier. But nonetheless, so I'm actually going to have to ask about that. I don't think we have to use matrix at all, because that pretty much proves it. But yeah, I'm going to have to ask about this. But yeah, so this, from as far as I'm concerned, this is legit to me, right? Because it does answer all my questions. It asks for a proof, right? It doesn't say you have to use matrix. Interesting. Anyways, so yeah, so that's something you could do, right? So, but that's A. B is this one. So this is where we have to actually plug it in to make sure that we know what we're doing. So this time they're asking, so based on what we sort of talked about in 18A, for 18B, you get this question. Ax vector equals to 4x vector. No? Find me what x vector is, right? So we want to know what x1 is and x2 is and x3 is. Sort of similar to what we've been doing in 1.1 and 1.2. But nonetheless, so I am going to try to isolate for x vector. Like finding out any unknown variable, right? So I just move the 4x to the left side. So it's going to be ax vector minus 4 identity a matrix times x vector equals to 0 vector. I just shoved an I right away just because, just for the you'll see why I did that on the next step. It says a minus 4I, right, times x vector equals to 0 vector, right? So it's just nice that there's I. You don't have to write it. I mean, it's self-explanatory, right? But I complicate things, so maybe it's not a good idea. But it's a little redundant, I know. But nonetheless, moving on, A is going to be this minus I just went right away. It's basically just 4 times identity matrix, right? And identity matrix is 1 0 0 0 1 0 0 0 1, right? So if I times it by 4, all zeros, if you times it by 4, it's going to be just 0. So the only difference it's going to make is where the 1s are, right? So it's going to be just 4 0 0 0 4 0 0 0 4, right? So I'm going to, and then all that times the x vector gives me 0. Every time, when you see this, something should trigger into your mind right away. Homogeneous, right? We'll talk about why that's important later. Well, not really important. You can still solve the question without appreciating the detail. But nonetheless. So, moving on. So, I just did the simple subtraction. So, 2, 1, 2. All I care about is the first 2, right? Because it's subtracted by the identity matrix with a leading coefficient, which is on the first column. So, 2 minus 4 is going to be negative 2. 1, 2 will stay the same. Second row, the leading coefficients on the middle, the second column. So 2 is going to stay the same. 2 minus 4 is negative 2. Negative 2 will stay the same. So the third one, the leading coefficients on the third column. So first 2 we ignore. 3, 1. It's going to stay the same. 1 minus 4 is negative 3. So same thing. And then now what's going to happen is here. So what's going to now, I just put x1, x2, x3 just for my own reference. You don't have to write that. But nonetheless, so we have this, and they all have to equal to 0, right? Just like what we talked about, right? It all has to equal to 0 vector. So that's why I say homogeneous solutions, right? So, but it doesn't really matter. We go through the typical elimination to simplify this as much as possible. So there's 2, negative 2, negative 2. I can divide both of them. I can divide this row by 2 to get a nice 1, negative 1, and negative 1. So I'm going to choose the second row to be my leading coefficient, get rid of the other competitors, and using these methods, I was able to make it 0. I was able to make it into this matrix. There's a competing leading coefficients in the second column, so use this method to get rid of that. Then I'm going to have this matrix, and then all I did was, is there anything else I did? Yeah, no, that's pretty much it, right? So after that, so once I have this, then we just look for solution, right? Ooh, interesting. Third row, all 0 rows, right? So because of that, we're gonna have to use a parameter, right? So, and the next one is 0, negative 1, 0, which means x2, right? Not y, right? x2 is gonna have to be. Okay, it's the same thing, but okay, yeah. Oh, no, sorry. Yeah, okay, never mind. Let's fall back a little bit. What I wrote isn't wrong at all. It's just what I forgot. There's another step here. So, minor step, right? So it's 0, negative 1, 0, right? So I just, times it by negative 1. So negative 1 times R1 gives me new R1. Okay. Don't write it like that. Write it a little more neatly, but you get the idea, right? So that becomes positive, and the rest stays the same. Okay, so if you look at this one, right? x2 equals to 0, right? So that's going to be x2 equals 0. x1, there's no x2, so skip that. x1 minus x3 gives me 0. So, and the last one is 0, right? So we need a parameter. So we're going to focus on x1 and x3, right? So because they're both, it could be anything, I'm going to have to set 1 up, right? So I'm going to say x3 equals to the parameter, macro, for example, right? So then if that's the case, then x1 equals to x3, and x3 is macro, right? Oh, I have to stick to that format. So x1 is going to be macro as well. So because of that, if we look at the solution here, so I just said, well, x1, x2, x3 equals to the x vector, which happens to be u, 0, u. Did I write it here? Well, I wrote it here, but I suppose I could write it here too. U macro is real number, right? So yeah, this is the solution they want, right? So yeah, that's all there is for 18. So actually not that difficult, right? It's just once you really break the steps by bit. But yeah, so that wraps up 1.6, and I will see you again for section 1.8. Yeah, and when I can't wait to do 1.9. I'm not sure if I can post it on 1.9 by this weekend because I haven't actually went through the questions yet. But yeah, 1.9 is so exciting. The traffic examples and Anyways, yeah, okay, sorry, I'm rambling now. So, anyways, yeah, I will see you back in 1.8. And yeah.